Okay. So here is my equation. Y equals X plus 3 plus 1. Okay. What tells me that this is a parabola? The square. The first thing I need to do is find the vertex. Let's do that together. So just like absolute value, 1, and this flips. All right. So we're going to put a dot at the vertex, which is negative 3, 1, located here. The step pattern, right here. We did this yesterday. 149. So let's count the step pattern. I'm going to zoom in so you can see real well. Okay. So I'm going 1. Then when you count, you got to come back to the vertex line. 1, 2, 3, 4. 9. 1, 4. Now you shouldn't have to count. Once you get one side of it, you shouldn't have to count the other side because of the axis of symmetry. So double check yours. Yours should have crossed the y-axis at 10. Look at yours, make sure it did. If it didn't, you counted wrong. The biggest mistake that I see is that when you count 149, you don't always go back to the vertex line. Okay, erase. Let's do, we're going to do a couple more together, and then I'll let you do some on your own. X minus 5 squared minus 10. First thing I need to do is write down the vertex. Negative 10. Instead of negative 5, I'm flipping that one, and it's 5. So that's the most important dot. Five, negative 10. Okay, in counting your 149, 1, back to the vertex line. 4, back to the vertex line. 1, back to the vertex line. 4, back to the vertex line. 9. If you did yours right, these two dots should have been right up underneath the x-axis. So step 1 is to find the vertex. Then you count the step pattern. Okay, you do this one. Actually, no, we're going to do this one again together. Y equals the absolute value of x. Oh, shoot, not absolute value. What am I thinking? Bad. Squared plus 3. Okay, the vertex here would be, what goes in this first spot? 0. Just like the absolute value, if there's nothing in those parentheses, it's a 0. So 0, 3. Count your 149. 1, 4, back to the vertex line. 9. 1, 4, 9. Now, please understand that if you were to connect the parabola, you know it's going to go on forever. It doesn't stop at this dot. There's actually, the step pattern is actually 1, 4, 9, 16, 25, 36, 47, but we don't ever have graphs that big. Let's do one where there's not anything on the outside. Y equals absolute value of x plus 5 squared, period. That's it. So nothing on the outside, that's a 0. Instead of 5, it becomes negative 5. It's located here. 1, 4, 9. 1, 4, 9. Okay? Y equals absolute value, or not absolute value, parentheses, plus 3 squared minus 7. Let me see yours. Make sure you label the vertex and then let me see it. Don't connect the dots so I can see your step pattern pretty well. Very good, very good. Okay. -3, -7. -3, -7. Now I'm 149ing this. 1, 4, 9. 1, 4, 9. Y equals x minus 6 squared plus 7. Label the vertex, please. It's positive 7. One, 4, 9. Okay. We're not done with the whiteboard. So this last page on this parabola investigation, we are going to find out what makes the step pattern change. The step pattern is not always 1, 4, 9. Most of the time it is. Here's what I need you to do. Look up here. On the back, graph your dots. This is like what we did yesterday. Graph both tables and see if you can answer the following the questions. In particular, see if you can figure out what the step pattern. I'm telling you, the step pattern is going to change. My markers are graded. I don't even think the first one's on the graph. Okay, anybody figure out, okay, the vertex, we shouldn't have had a problem with that. Vertex was 0, 0. Opening obviously is up. Okay, step pattern. Oh, I'm frozen. The step pattern. The original step pattern is 149. That is the OG step pattern. That is the original, but this one changed. What did this change to? To 818. 2, 8, 18. So 2, 1, 2, 3, 4, 5, 6, 7, 8, and then 18. Now, I'm going to mark that out. Go into the next one. So vertex 0, 0, opening, down. The original is 149. This one was, well, -3 because it's down. 3, 12. And then this would have been 27, even though we might not have been able to count it. So look, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then if we counted down, we would be at 27. Now, the real question is, how or what in the problem, in the equation, made the step pattern change? Any ideas? Well, all the other ones had a 0, 0. The one on the very front had a 0, 0 vertex, and it was 149. So what makes this go 149 and bump up to 2, 8, 18? What's the only number in this equation? 2. Look here. The number in the front changes the step pattern. That's what you multiply the step pattern by. Look here. So the original is 149. There's a 2 out in front. 1 times 2 is 2. 4 times 2 is 8. 9 times 2 is 18. Right here. The original step pattern is 149, but there's a -3 out in the front. 1 times -3 is -3. 4 times -3 is -12. 9 times -3 is -27. Let me show you how that's going to look on your whiteboard. Normally, we've been dealing with this. +3 minus 8. Go ahead and plot your vertex there. Do not 149. Go ahead and plot your vertex. -3, -8. Okay. Now, this would be a 149. I want to show you where that number is going to show up. Look up here. The number, so originally our step pattern is 149 is the original step pattern. 149. Okay. If there is a number on the outside here, that's where it's gonna be. So this is what it's gonna look like. Everybody's eyes need to be up here. This is the last change you're gonna have in a parabola. The vertex, you find the same. You are not distributing this 2. The vertex is the same. This 2 multiplies the step pattern by 2. So instead of 149, it is 2, 8, 18. So when you graph it, it's going to be, you do this on your board. Count the step pattern. Instead of 149, it's 2, 8, 18. Two, 8, 18. It just stretches the parabola. If there is no number on the outside, the step pattern is 149. Whatever the number is on the outside is what you multiply the step pattern by. So let's say it was the same vertex. Let's say there was a negative out there. That's -1. 1 times -1 is -1. -4, -9. So the step pattern here would be -1, -4, -9. 1, 4, 9. Okay, here's what I want you to do. I'm going to give you a problem. I don't want you to graph it. I want you to tell me what the step pattern is going to be. Don't graph it. You tell me what the step pattern is going to be. So, no. Yes, yes. Good. You should be multiplying every single number by 3. So the step pattern here is 1 times 3 is 3, 4 times 3 is 12, 9 times 3 is 27. So the step pattern is 3, 12, 27. Let's change it. What if it were 5? So most of you are getting it. 1 times 5 is 5. 4 times 5 is 20. 9 times 5 is 45. You're not counting by 5s. You're multiplying the original step pattern by 5. Okay, what if it was -2? -2. But negative on all those. This parabola would be going upside down. So -2. 1 times -2 is -2. 4 times -2 is -8. 9 times -2 is -18. Same problem. Don't graph it. Tell me what the vertex is. Write down the vertex. You don't have to plot it. Just tell me what the vertex is. Good. What is the vertex? That's the step pattern. So the vertex is not changed, guys. That's what we've been doing for 2 or 3 days. That's -2. Vertex is -2, -8. Okay, go ahead and put your whiteboard away.